Master web development with Skill Bakery. Hey everyone, ready to level up your web dev skills? Introducing skillbakery.com premium courses starting at just $6 or 500 rupees. Sign up today and learn in-demand skill sets. Unlock your potential today at skillbakery.com.
Hello and welcome to another exciting video. In this one, we'll learn using WebAssembly with Rust. WebAssembly defines a binary format and a corresponding assembly-like text format for executable code that can run in web pages, and that with a near-native performance. It is also designed to run alongside JavaScript, allowing both to work together. WebAssembly's major goal is to allow developers improving the performance of certain parts of their application to, in the end, improve the user experience. The best part, WebAssembly is a standard and supported by all major browsers. While many languages still work out a compilation story to WebAssembly, Rust is ready for prime time. Rust is a relatively new language and a great replacement for C and C++. In addition to that, Rust WebAssembly team has got some sophisticated tools like Wasm BindGen to make the interoperability seamless. In this lecture, we'll start from the beginning, demonstrate how to load a module, and then gradually build up until to a point where we use Wasm BindGen to invoke functions and pass data between JavaScript and Rust without a hassle. So let's go ahead and do the first thing, verify whether Rust is installed or not, and that you can do by typing this command rustc. And here you can see in my PowerShell window in Visual Studio Code, I am getting this prompt that simply means that Rust is installed. And if you are new to this, do watch our first lecture on this one where we see how to install Rust. Now, once we have installed Rust, the next thing that we need to do is add the WebAssembly target to our Rust installation. And to do that, we make use of the rustup command. So we write rustup and then target, and we add this keyword add wasm32-unknown-unknown, and you press enter. So this is going to install WebAssembly target if it's not already there. Otherwise, you'll get this command that the component Rust standard for target this is up to date. Now, once we have the WebAssembly target, the next step is to install the necessary tool. By necessary tool, I mean the Wasm pack, which simplifies building and packaging Rust-generated WebAssembly code. And to do that, we will be making use of the cargo command install Wasm pack. And there we go. If you already have Wasm pack installed, you'll get this message. Otherwise, Wasm pack will be installed on your machine. After this, we'll be creating two directories. One is for the Wasm Rust project, and the other one will be for the web project. So let's go ahead and first of all, create the Wasm Rust project directory. So here I'll be making use of the command mkdir, and then Wasm Rust project, that's the name of the directory. Press enter. So here that directory will be created. Now let's go inside that directory. So we'll say cd and Wasm Rust project. Once we are inside that directory, we'll be creating a Rust library project. Now, in order to create a Rust library project, we make use of the command cargo new, then the flag --lib, and here we'll be going ahead with the prompt wasm_project. So this is the library project that we are trying to create. Once that project is created, you will notice that we have something coming up in the left side navigation bar, and here we will have to now update the cargo.toml file. Now this is going to contain two things. The dependency will now have the Wasm BindGen version, and the create type will be cdylib. So here the library will be included, create type cdylib. Now these two things are part of the cargo.toml file. After this, you will explore the src file, and here you will find the lib.rs file already created. Now, we don't need this one. We'll be starting with a very simple hello world example. So what we'll do is we will delete this whole thing from here, and we'll be making use of the Western bind gen, and here we'll have the prelude. Now once we have this line, the next thing is we'll be making use of the Western bind gen directive, and now we'll be creating our first function. Let's call it as greet, and it is going to take name as one of the parameter, string slice reference, and it's going to return a string as function return type. And here we'll be making use of the format, and we'll say hello and then the name. So that's pretty much it. We are creating a very simple greet method. Now this greet method will be called from HTML file using JavaScript. Now we have to build this project. In order to build it, we'll be making use of the Western pack build command, and this is going to target web. So you can see that we are making use of another flag dash dash target, and then we are telling it where exactly this needs to be packaged for. So this is for the web, so we say web. And here, first of all, we need to get inside the directory. So let's go ahead and do that. Wasm project. So this is the directory, Wasm project. So once we are inside the Wasm project directory, we can go ahead and start with the command Wasm pack build target web, and this is going to package it now, as you can see. So we now have this compilation going on, and once it's done, we'll have a directory of sorts. Like over here you can see pkg, and within that we have this wasm project.js. Now this particular file that gets created or generated using the wasm build command will be referenced in our HTML file. So using that, we will be able to call this function greet. Now we are done with the web assembly part. Now it's time to create the web application. So let's go ahead and clean this first over here. And now we will be going outside this directory. And here we'll be creating another directory. So let's call it as mkdir. And this time around, we'll be creating our web app for Wasm. So we'll say Wasm web app. And now the directory has been created. We'll go inside that directory. So let's do that. So the directory name was was-web-app. So we are now inside the directory. And inside this directory, we need to create a particular file. Let's call it as index.html. Now, inside this, the boilerplate template will be pretty easy. So here we have this code title, and let's close this with the remaining part of it. So here you see a very simple HTML page. It's having this div as output, and here we have title. The next thing now is to include a script tag. So let's go ahead and do that. So here we have our script module, and this is going to be of type module. So by default, it takes JavaScript. So here we tell that this script is of type module, and within this we will have to import a couple of things. So let's do that. Import init, and then you remember over here in our lib.rs we created this greet method. So that is what we will be referring over here, and from where exactly we are getting it. So if you see, we have this package directory, and that package directory is inside the Wasm project, which is outside this was web app directory. So here we'll have to provide a relative path to it, which is like this. So we say Wasm project, and then we will be targeting the package directory, pkg. So that's the package directory. And here, as I mentioned, we will be referring to this particular wasm underscore project.js file. So let's go ahead and do that. Wasm underscore project.js. And once we have this import statement, the next thing is we can make use of the asynchronous function. So we say async function run, and here inside this we say await init, and then we create a constant greeting, This time we'll be passing this value to the method. Let's go with the old school world. So if you notice in our lib.rs greet method, we already have this hello. So we are passing this name now, and the name over here is world. So this ideally should print hello world. So here we'll say document.getElement by ID. And if you see, the HTML has this output ID. So here we'll pass that. And the inner text property we can use to assign this greeting, and that's pretty much it. The method has now been defined, and what we need to do now is make use of it. So how do we do that? Just call it over here after the definition. So when this page loads up, we will get the output as hello world if everything is working properly. So now what we need to do, we are already inside this web app directory. We can go ahead and click on this go live extension, which kind of runs HTML pages in local host environment. So clicking on this now, you will get this message, hello world. So here we have this await init. Make sure that it is executed. So here we have await init, and after that we are passing this greet method. We're calling this greet method. Now this greet method, as I mentioned, world is being passed out. If I go ahead and say any other thing over here, Skill Bakery, and save this, the page will be refreshed, and here you can see Skill Bakery is coming up. Let's do it side by side so that when I make some change over here, you'll be able to see it in action. Going back to hello world, and let's save this. There we go. So here what we have done is we have taken one HTML file, and in that HTML file we have created a script. We have called the WebAssembly from Rust and made use of the method that it provided. If I go ahead and show you over here in the developer console, and let's reload this page. So here you can see a couple of things being loaded, and one is the index.html, the other one is the wasm project.js file, and then over here you see the WebSocket, and then we have the wasm file. So this is basically the file that is actually getting executed when we are passing this variable world and calling this method greet, and then it's returning us the result over here as hello world. So what we have covered in this, first, how to set up for WebAssembly using different packages. And then we've also seen how we can load a WebAssembly function written in Rust, and we have invoked it from.
If you find the video helpful, don't forget to like and subscribe.